In today's video, we're going to be talking about something called dimensional analysis. After watching this video, you should be able to convert units from one form to another and understand what a ratio unit is, which is a term basically I kind of made up or coined, but it's really an important concept. Once you get it, it's actually pretty easy, but it's something I really recommend you try to learn quickly, because it's something that pops up over and over again in this course. So try to learn what a ratio unit is. All right, let's get right into it. In this class, we're going to have to do a lot of conversions, going from, pounds to kilograms, or kilograms to pounds, or meters to centimeters, or all these different types of things, changing years to seconds. Those type of conversions can be done with a strategy called dimensional analysis, and basically what it's doing is you're figuring out equivalent amounts using different units, and then you're going to be multiplying fractions where one part of the fraction has a 1 in it, either on the top or the bottom. So it just kind of depends. And basically the big key to doing these problems is you really want to focus on the units. Okay, focus on the units, more so than the numbers actually, because the units need to cancel out. And when you start canceling out units, you should be left with the unit that you're trying to go for. So if you're trying to go from like years to seconds, that's what you should be left with, is just seconds, and that would be your answer in seconds. So I'm going to give you an example right now. Okay, so the question is, convert your age in years and months into seconds. Okay, so typically when someone asks you, hey, how old are you? Usually people will say, oh, I'm 16 or whatever. Okay, so I am going to say I am 30 years old, okay, which is almost true. And basically we know that 30 years, or hopefully you know at this point, that 30 years, it's really, you could actually put a 1 underneath it, right? You can make this into a fraction. 30 over 1 is 30. So 30 years, okay? And in this problem, we're going to assume all the months have 30 days, which I know is not true, but we're just going to assume that. And we're going to assume there are no leap years, okay? So we're going to make the math a little easier, okay? So 30 years. What I need to do is I need to cancel out years. And so I'm going to multiply this by, I'm going to put years on the bottom. Okay, I'm going to have 1 year. Well, how many months are in 1 year? Well, hopefully you know that there are 12 months in a year. Okay, so I'm going to put 12 months on top. You'll notice 1 year is the equivalent of 12 months. And what I've really done, though, this is what's important, is I've allowed myself to now cancel out years. Okay, they are gone. All right, so now I'm left with months. So if I want to figure out how many months old I was, I could just take 30 times 12 and I'd know how many months old I am. But that's not what I'm asking. I want to know how many seconds old am I. Okay, so now I'm going to multiply months. I'm going to put 1 month on the bottom. And how many days are in a month? Well, we're going to make this assumption that there's 30 days in 1 month. Okay, so 30 days. So in a month, there's 30 days. Now, I'm going to put 1 day on the bottom, so my day cancels out. How many hours are in a day? Well, there's 24. Okay, last time I checked. 24 hours. Okay, and now days would cancel. And now I'd say to myself, well, how many minutes are in 1 hour? And hopefully you're thinking 60 minutes. Okay, and I clearly write too big, but if I could fit this in here, this would go right here. It'd be multiplied by how many seconds are in 1 minute. Well, hopefully you know there's 60. Okay, so this whole big long thing, let me change pen colors here, just so we can, let's do yellow. So I can show you canceling out. Here we see years cancels years, months cancels months, days will cancel days, hours will cancel hours, and then minutes cancels minutes. What are you left with? Seconds. And this is where I'm kind of telling you about the focus on the units piece. Okay, if your units work out, the math itself will relatively come easy. Now it's just basically throwing numbers in a calculator. So I'm going to take 30 times 12 times 30 times 24 times 60 times 60. And if you do that math in your calculator, it'll get you some big number, but it's about 9 times 10 to the 8th seconds. And this is in scientific notation. Okay, 9 times 10 to the 8th seconds. That's how many seconds old I am. 9 times 10 to the 8th seconds. Okay, pretty old. One thing also you should notice is that in all of these fractions, there is the number 1. Okay, and that should be true in any dimensional analysis problem that you do, that there should be a 1 somewhere. Now, in this case, they all were on the bottom. That's not always going to be the case. In my next example, I'll show you when that's not the case. But there should be a 1 in your fraction somewhere, okay, to make life easy. So here we go. It says, convert your weight into kilograms. Okay, and I tell you, 1 kilogram is about the equivalent of 2.2 pounds. Okay, I am about a 200-pound dude. Okay, I'm in yellow. That's good. I weigh about 200 pounds. Okay, and we can say that's over 1, if that helps you see things a little better. So I need to get rid of pounds, and I want kilograms on the top. So I have kilograms on the top, pounds on the bottom. Okay. How many pounds are in 1 kilogram? Well, we said there's 2.2 pounds in 1 kilogram. So I'm going to put 2.2 pounds down here over, or 1 kilogram over 2.2 pounds. Okay. So now you'll notice, let me change pen colors real quickly here. Wish there was a faster way to do this, so we'll do cyan. Pounds cancel, and what are you left with? Kilograms. Okay, so now it's just calculator work. What is 200 divided by 2.2? Well, 200 divided by 2.2 is about 90 kilograms. Okay, so that would be my weight in kilograms. If I were to, you know, I don't know, go into a country that uses metric, I would say, oh, I'm about a 90 kilogram man. Okay, that would be my weight. So as I mentioned earlier in the lesson, your units are really the key to doing dimensional analysis successfully. The very first example I gave you is changing my age from years to seconds. And so the units were the tricky piece, I guess, where you're going from years to seconds. And basically all the other units, when you're doing your dimensional analysis, should cancel out. So just make sure you end with the right units, and by doing that, you're able to kind of catch yourself from maybe making some mistakes. So we'll use a real simple physics formula, where this basically is a calculation of distance equals velocity times time. And I'm asking the question, what is the distance traveled if the velocity was 10 meters per second over a time of 7 seconds? So the first question I might ask myself is, well, what units is distance measured in? And we should know by now that distance is measured in meters. Okay, so that better be what my dimensional analysis comes out with when I'm all said and done, is meters. If I come out with seconds or something else funky, then I probably know I did something wrong. Okay, so basically what I'm going to do is I'm going to put down my formula, D equals V times T, and I'm looking for distance, and my velocity is 10 meters per second times time, which is 7 seconds. And sometimes for dimensional analysis, I'll put a 1 underneath it just so I can kind of see things. So this is a 1. 7 over 1 is still 7. And this seconds, I certainly can put a 1 here. If that helps you to see things better, be my guest. And so here is our equation, 10 over 1 times 7 over 1. And let's first make sure our units cancel. So let me just quickly change pen colors. So seconds cancel here, and there's nothing to cancel down here. So what am I left with? Well, I'm left with meters, right? And that's what I was looking for. I wanted to find an answer that gave me meters. And so if we do the math, 10 times 7 would be 70 meters, and that would be my distance. Okay, and that's just a key to basically being able to check your answer, if you will. The math hopefully will come pretty easily because you're just punching numbers in the calculator if you have to. But if you get the wrong units, typically you're going to lose some points in your problems, and that's a bummer. One last concept I'd like to talk about is something called ratio units. And it's not something you'll find in your book, but it's something that comes up throughout the course. The entire year you will see these things called ratio units, and again, it's not really so much named that in the book, it's just kind of assumed that you understand what a ratio unit is. So something I think most of us can relate to is buying stuff. Okay, and so I'm going to make an analogy here. Let's say someone is interested in buying apples, and the store is charging $2 an apple. Okay, let's say they charge $2 an apple, and that's supposed to be a dollar sign. Let's say I buy 3 apples, right? How much would that cost me? Well, if you have $2 an apple, if I buy 3 of those, it would cost me $6. Okay? This right here, actually, believe it or not, is a ratio unit. For every $2 you spend, you're going to get 1 apple. All right? And let's take that a little further. Let's say you want to buy 10 apples. All right? So 10 apples, how much would that cost? Well, 10 apples would cost $20, right? That's how much it would cost you. Another question I could ask you would be like, well, let's say I go to the store and I only have $12. How many apples could I buy? Well, I could buy 6 apples, right? With my $12, I could buy 6 apples. All right, and this is basically a price, if you will. So an example of a ratio unit in physics that will come up relatively soon here is something called velocity. Okay? Velocity is a ratio unit because the units of velocity is meters per second. Okay, so let's say I say a toy car has a velocity of 3 meters per second. What is that actually saying? Well, we can actually put a 1 next to this second here, and we have 3 meters over 1 second. So what that means is that car moves 3 meters every second. So I could ask you, well, how far did the car move, say, in 3 seconds? Well, in 3 seconds, the car would have moved 9 meters. I could ask, well, how far did it move in 5 seconds? Well, you could say it would move 15 meters. And this is what I mean by a ratio unit, is basically there is a fraction of sorts. And typically you're going to have a number on the top and then a 1 on the bottom. Another ratio unit that might not be quite as obvious is the unit of power. The unit of power is something called the watt. Okay, and this, to me anyway, is a really helpful way to learn what power is, and we're not there yet, so don't really worry about this too much. But a 1 watt is equivalent to 1 joule per second. Okay, 1 joule per second. So let's say you have a 50 watt light bulb. What does that mean? Well, basically it's using 50 joules of energy for every second. Okay, a 50 watt light bulb is 50 joules per second. This too is a ratio unit. Okay, it's a ratio unit. Something that is not a ratio unit would be something like, we'll say, distance. Okay, what is the unit of distance? Well, that's just meters, right? It's not in a fraction of any sort. So this is not a ratio unit. And if you're still kind of confused on this, don't worry. It's not a big deal yet, but it'll continue to come up, and kind of getting this intuition on what a ratio unit actually is and what it means when you say, a car is moving 3 meters per second, or a light bulb has a power rating of 50 watts. What does that actually mean? What is that telling you? Yeah, to me anyway, it's really helpful in terms of learning the physics. That takes care of this video. I will see you guys next time.